My name is Richard Turner and I'm standing in an anechoic chamber, a room designed to eliminate ambient sounds. When you're standing inside this chamber, almost no sound from the outside world enters your ear canals. The silence is so absolute you can hear the blood pumping through your veins. I've come here to explain the ideas behind technology we are developing at the University of Cambridge's Department of Engineering to rub out noise. Whilst this anechoic chamber removes all sound, the technology we're developing will rub out certain sounds selectively, and our aim is to develop intelligent hearing aids that can adaptively remove interfering background sounds that users don't want to hear. Many of these background sounds are referred to as audio textures, and to explain what audio textures are, I'm going to play some recorded sounds I made whilst I was on a recent camping trip. In the recording, I start by a campfire, and then you can hear my footsteps as I walk past the stream. The wind gets up and so I unzip my tent and get in just in time as it starts to rain. All of those sounds, burning fire, running water, howling wind, pattering rain, are audio textures. And like visual textures, they're made up from lots of small independent events, like a single drop of rain, that combine to produce the sound of the texture. But here's the remarkable thing. All of the sounds I just played to you are synthetic. They were made by taking a very short section of each sound, training a computer so it learns the statistics, and then generating entirely new sounds. Now, the new sounds have very different waveforms from the original. The synthetic rain sound, for example, has an entirely different pattern of falling raindrops. However, they have the same statistics as the original, and that's what's important for how the human brain perceives them. This is a cute trick and may have had you fooled, but what's the point, and what's this got to do with hearing devices? Well, current hearing devices perform extremely poorly in noisy conditions like this restaurant, for example. In many ways, this is the exact opposite of the anechoic chamber we're in just now. There's lots of ambient noise and reverberation, and people with cochlear implants and hearing aids find environments like this, or blustery days, or traffic noise extremely challenging. Wouldn't it be great if a hearing aid could detect environmental noises and automatically remove them? Well, the statistical description of sounds that we're developing allows us to do just that. Think of a spam email filter as an analogy. If I know the sorts of words that appear in spam emails, that is, the frequencies with which words typically appear, I can filter the spam out. We're applying something very similar to hearing devices, where instead of using word frequencies, we use the statistical model of the environmental noise to detect it and to remove it. We hope that these ideas and the methods will lead in the future to intelligent hearing devices that can adapt and learn from the acoustic environment.